Good morning, everyone. Thank you for joining. Can you all hear me? Am I okay? Yeah, I'm
Yes, Nandini, we can hear you.
all right. So let me take a minute and then introduce about this RISE and Women Who Code, and then we can get started with the session. So the RISE Reboot, Invest, Scale, and Empower Yourself is an initiative from Women Who Code Hyderabad chapter. This is to enable women on a career break to return to work. And the whole purpose of Women Who Code is to inspire women to excel in technology careers. Thereby, they can create a world where diverse women are better represented as engineers and tech leaders. And there is a code of conduct for women who code, and everybody gets an equal opportunity here to participate or to volunteer, irrespective of their demographic characteristics, political affiliation, or socioeconomic status, or their preferred programming language. And Women Who Code does not tolerate harassment of members in any form. So please read the whole code of conduct at womenwhocode.com/code of conduct. So with this, I will hand it over to our previous trainer, Kannan. And Kannan, special thanks to you for accepting to take an extra session on the request of participants. And I mean, it was so nice of you to spend your time on the weekend to help somebody else. Thanks a lot, Kannan. Over to you. I'll stop sharing my screen. You can start sharing your screen.
Thanks, Nandini. So we'll quickly get started over with the topics. So let me share the screen. Yeah, hope my screen is visible now.
Yes, we can see your screen.
Yeah, okay. So fine. So we will start from the previous day's session. So wherein we started about two different ways of implementing the threads. One is to have the class thread to be used with extents, and the other one is to use the runnable interface. So then we came across one thing that is called synchronization. So how to use synchronization and how it helps while running two different threads. So one practical example that we see, we did see on the other day was the use like the stocking of the material in a shop while going for a shopping, and if the stock is not available, so we need to wait for the stock to be loaded, and then we went in for shopping again. So that kind of synchronization example would I hope would help you understand how threads work when there is a synchronized environment, right? So the next one is to go into the important part of the threads, that is to understand the life cycle of threads. So the screen that I'm sharing now, the presentation, so it shows the various status to which a thread can go into. And so whenever a thread is being created, so what happens here? So thread is like a kind of a small process within a big process. So anytime a new thread is being created, so it goes through different stages of its life cycle, and eventually it goes to terminated or its life ends. So whenever there is a new thread created, so you can expect that to start working by getting into the status of new. So a newborn thread is ready to be run, it is not yet started. So whenever you instantiate the thread class, the thread object, so now what happens is it comes to the newborn status and it is ready to run. So ready to run means like it is runnable. So it is active thread. So when it becomes an active thread, it can be of two different status. It can be either runnable or running. But from start, a newborn thread, it will obviously come into runnable status, which is like it is ready to start its process. And then when the current status goes on, like when the memory or the allocation is free, then the processor will take up the runnable thread and will start the execution, and then the status becomes running, right? So yes, so once it starts running, so is it going to run smooth? So there could be some problem in the sense, maybe like why we go in for something like a resource. So when we try to reach out some resources or some, it can be a simple object to other level of going into external resources like file systems or DB or whatever. So in that case, if there is a resource that is not available to ensure that the thread is completely running, then what would happen is it will go into a blocked or the waiting state. So that's the non-runnable state you see in the left side. So wherein the thread will go in for waiting, right? So what happens when the thread goes in for waiting? So it is going to wait for some time unless like there is some kind of notify or notify all from any other thread that is using the resource. So there might be some other resource that is trying to handle your, the log. So what happens here is that the other thread that is using the resource, it has to notify saying that I have completed my work. Now the resource is all free. Anyone who wants to take it up, you can go ahead. So that's a kind of notification that we are going to get from other thread that has released its log from the resource. Then the waiting thread will get the notify, and then it goes back into runnable status, and then it is ready to run. And if the processor picks up that thread, and then it comes to running status, and it tries to finish off all its process, and it goes on to the dead status. So now the thing is, what happens again if you come back to such a block? So again, it goes on waiting, then it waits till notify or notify all. So, and then it goes to runnable and running. So this cycle goes on. So is it possible only for the JVM to push a thread into a wait mode? No, it is also possible for us to put a thread into a waiting status, and that waiting status is kind of a timed waiting, and that is called sleep. So you can push a thread which is running by implicitly calling a sleep method in order to ensure that it is waiting for some time, maybe like a timed wait. So for that particular amount of time, whatever we give, like let's say 5 seconds or 10 seconds, like however long you want to make it wait. So you can intrinsically provide a time till it can go into a sleep mode, right? So the other one can be a blocked status, wherein like the total resource itself is not available, or like, so you are just waiting for something, and it can sometime eventually become a weak thread or kind of a non-runnable thread. So, and that becomes a blocked status, wherein the resource is totally not available for the usage, right? So these things are the different status that you can expect a thread into when it is alive. So once everything is complete, so the thread gets terminated and it is moved out of the thread cycle. So clear so far? Any questions?
Clear, Kannan.
Yeah, okay, thank you. Thank you. So now what we are going to do here is we'll just go into some simple code snippets. I'll explain you the life cycle of thread, and then I'll show a simple example of having like a kind of a thread pool, and then like, how to group threads. So that would be one another example I would like to show today. And at last, I wanted to show a real-time example wherein like we can see how inter-thread communication happens, and how you can ensure all these threads work together to provide a single kind of process. All right. So now let's go into the states, the different states of the thread that you can expect it to be. So I'll just go into Eclipse. I'm sharing it. Just a moment. Okay. All right. Is my Eclipse visible?
Yes, Kannan.
So I'm just creating a new the thing called a thread state. Okay. Okay, good. And then we'll just have this up front. And then we can just start creating one more class, maybe like just called a class state runner. Okay, so which is going to implement runnable thread. All right. So what I'm going to do here is, so because I implemented runnable interface, I have to provide all these like implemented methods. So the implemented method for an interface would be run. Right. So this run, what I'm going to do is I'm going to use a try catch block. Right. Catch. Exception. Right. So now what I'm going to do is I'm going to make thread sleep for some, let's say, 1 second. All right. So then what I could do is I can just simply come out of the catch block, maybe. This is out. And then say, okay, so let me another like another catch. So I'm going to create one more thread here just to understand how two different threads would eventually work. So you have two different try catch. All right. So in the second thread, what I'm going to do is I'm just going to make it again sleep, and this can be for 2 seconds. So just like the difference is 1 second, and then like we have two different threads that are getting started. All right. So now what I'm going to do is I could just say state of thread. All right. What I'm going to do is I could just say thread state. Okay, we'll just create something and then come back here. Now, back to the original main class wherein we are going to start up something here, right? So this class is also going to have kind of implementation, that is implements runnable. All right. So we are going to implement runnable interface here, and we have the main method. And what we are going to do here is we are going to create some static threads. Static. And then thread, let's say call it as T1. All right. So if T1 is the case, then we can go ahead and say T1 dot get state. Right. So now we have a thread. So I have a class created and I have a static thread within that. And then I'm going to create an object, right? So that object is going to be a kind of a thread state object. All right. So this is going to be, okay, let's keep it as object. Fine. So now what I'm going to do here is I'll just remove this. So this object is going to have a new thread object. All right. So the thread state, whatever we are trying to capture. So we are going to have a new thread state, right? Right. So now what we are going to do is again, so this thread state, we need to pass it on to the actual thread so that we are able to capture what is this actual state that this object is going through. So it's going to be the tracer. So we are going to put like it's more kind of like to put a practical example to this. It's like putting a GPS enabled phone into someone's bag to trace where he is going or which location he is currently now. So the person is going to be our T1, which is our thread, and thread state, the object that we are creating, is going to be capturing the different status. So it is going to be the mobile phone that has the GPS connection. So it is going to give us the location of the status of this current object, right? So now what we are going to do here. So we will just say this out. Please feel free to stop me if you don't understand the code anywhere, because I wanted to make it real fast. All these three are real good examples I wanted to share. And the other thing is like, yeah, it might take a little time to type in, but just every line of code that is being typed, hope you will be able to understand. Right? State while starting. All right. So now we could just go and immediately get the thread state and say get state. So now what we are going to print is while starting, what happens to the thread? What is the status of the thread? So once the thread is started, so the next thing that you have to do is this going to be like only a thread that is going to be here? So we need the implementation method for Runnable, right? So because we implemented this as thread also. So what you're going to have is another run method for the actual class. And within this actual class, what we are going to do is we are going to create another object for where the state runner. This is another class wherein we have implemented thread implementation too. So state runner, okay. So that is going to be my object, and that is going to be like a new of state runner. All right. So I'm creating an object for another thread, and that thread is getting initiated from here, and let's call it as T2. Okay. So new thread. Okay. And then what we are going to do, we are going to pass on the state runner into this one. So that would be T2, right? So we have two different threads now. First one, we have initiated directly in the main method. We have passed on, we have provided the locator, the state, provider. And then like, we are just setting it like get state will provide you the current state of this object. And similarly, we are going to create a state runner object, and then that object is going to be considered like a thread. Now we have created a thread here, and let's see the status of this object, and then say state. Okay, let's call this as T1. All right, state the state while starting T2. All right. So here we are going to just again say T2 dot get state. Now what happens? So the state now will be ready, right? So it is not still not even runnable because we have not even called T2 dot start. All right. So this is still only a newborn thread. It is not even executed yet. So the state is still. Now, if I print this state after starting T2, okay, So here I'm going to print this after this line of code, which is like t2.get state. All right. So now so far we have created so many things, and we'll run this code. And if you see the thread while starting T1, it is actually new because we haven't given a start here. If you notice that we haven't created a start here. So now what happens? So the thread is still in new state, right? So then what we are going to do here. So the next thing, sorry. So the next thing here, we are going to initiate this thread. All right. So just like what we did here, t2.start. So we are going to say t1.start. All right. So now let's print the state after starting T1. So here we will just print T1.get state. And if you see the status now, because this is in run method, so far that object was not created yet for T2, right? So the thread 2 was not even started, or it is not even born because we are not calling the thread method, the run. So we haven't created any object here, or we didn't start the thread, which is like the runnable for this current class thread state. So T2 did not start so far, but as soon as you call T1.start, you know what happens? The thread gets started. This class object is getting started as a thread. And now when a thread is started, what happens? Immediately it will go to the run method of the thread. Correct? So once it goes to the run method, here we are calling t2.thread new object and then start. So now what happens? The thread was started, and so the print here will show runnable. The state is runnable. Right? And then the new state is created for T2. Here we call start. What happens in new thread when it is given a start? It becomes runnable. All right. So once it starts runnable, so it is running through the thread here. It runs this method state runner and then comes to the run, finishes up everything here. And finally, everything is over. Now what happens after the sleep time that we have provided? The thread goes to terminate. Clear so far? So that would be the different stages through which a thread can run. And we can also try to implement more things and see different interruptions also. So are you clear so far?
Sorry, can you go up? So in this run method, so you're telling us thread.sleep. So which
Yes.
thread does it point to? Is it T1 or T2?
T2. T1 is a thread created for.
I don't understand that part of code where that is getting interrupted.
No, we haven't still gone into the sleep. I haven't gone into explaining the sleep method. I'm just explaining new runnable alone. Like terminated, I'll explain you why. Because thread is getting completed, it will print terminated after 3 seconds because it is sleep 1, sleep 2 seconds. So after 3 seconds, obviously terminated will come. That is fine. But now I haven't gone into why what happens when the sleep is being called. I'll explain you that. But before even going that, we are just having a new, and when you call start, it becomes runnable. Do you understand like these 4 lines of print that happens here, like new runnable? So how it happens between T1 and T2?
So after T1.start, the run method is getting called, right?
Exactly. So, whenever you have a class, that implements thread. So when you say start, as soon as you say start, so it will go into finding the run method inside that class. Any class that uses it becomes a thread only if it has a run method, right? So if you see implements runnable, as soon as you provide runnable, it will say if you don't give a run method, it will ask you to say provide unimplemented methods. So then you have to provide a run method. Within run, whatever you have provided, whenever an object is created for state run as a thread and say dot start, obviously it will end up here, which will be the first thing that it will run. So public void run. So that will be the method that it will start with.
So in this run method, so immediately it goes and it initializes the thread T2.
Exactly, T2. And then I'm also having T2 dot start.
Yeah, but here when we see the output, it is saying that starting the new thread, and then immediately we get the next one, right? The state after starting. That will actually, this SOP will get printed only after running this run method.
This run method, yes.
Yeah. So
Yes.
in between, it has to do the T2 only, right? After that only I need to get T1
No, no,
because
no,
this.
no, no. No, see,
Okay.
one
I
second. So
don't
you're
understand that
mistaken.
part.
Okay, one thing. See, what happens is, I'll go back to the slide and show you what happens here. So there's a newborn thread. What is a newborn thread? Nothing. You come to this line of code here. When you say new thread object, so in this line number 45, right? So this is a newborn thread. Okay. So do you, let's say, so do you understand like object instantiation and object references? You understand the thing between object and references, right?
Yes, object instantiation is like creating new.
Exactly, new. And then reference is more kind of an address or the name of that object, correct?
Yeah.
Right. So let me put it in simple words. Like let me call myself like so I'm a boy. My name is Kannan, right? So imagine like on my birthday, like on the day I was born. So how would have the announcement been made? Like there is a newborn baby. It's called a boy baby, right? With name Kannan. All right. So this is what it is going to happen. So now what to put this in Java language. So how it is going to be. So there is going to be a boy, which is a kind of a reference. And the boy name is going to be a Kannan. And who is Kannan? A newborn baby. All right.
Okay.
So this is a little translation of what I was telling. Like if there is a boy born and he's provided with a name like Kannan, you know that is a type of a baby called boy or a girl, right? But you are going to name it as Kannan. All right. So this is what it is.
Okay.
And then and then when it comes let's say Kannan. Okay. So now so far you understand, right? So this
Yes,
little translation, this little translation, you put this back here on the thread object. See here, T1 is a new thread object I'm trying to create. Okay, new thread, nothing. New thread I'm trying to create. And this thread is not just going to have like, a process getting started. It has to know which object I'm going to use, which class should I make it as a thread. Right. So this thread state, if you want to get a get state like this, like, the state of this one. So you have to pass on some properties to your thread, correct?
Okay.
So this is what I said. Consider this like someone you say like, you're a police officer, you want to spy someone, right? So what you do, you put a GPS on his back or like in the cinemas. So you put a tracking device. All right. So this object, the thread state object, whatever I created is a tracking device. I put in his back in the thread object. All right. So a new thread is created with the name T1 and it is having a tracking system implemented, injected into him. Right. So now I'm trying to get his state, like status or location, wherever he moves. Now nobody is calling him. It is just newborn. Right. So what happens? T1.getState will be new.
Okay.
Right. So so far we have only had a new object created in the memory, but we haven't started the execution of the thread. Correct.
Yes.
So now what happens? I call T1.start. I'm going to kickstart that. So if I start it immediately, the T1 will have T1.get. If you put the T1.get state, because I called start, it is moving into status called runnable.
So it means that it doesn't go into the run method immediately after T1.start?
No, there is a time, there will be a little time difference, right? So the execution, this is called threading. It is not a sequential code execution, right? So when you say threading, it is going to spawn new threads. It is going to have sequential execution.
Okay.
So this is one, this is one reason why you have concurrent modification exception, right? So let's say you are going through a while loop, suddenly you want to you saw an object and you want to delete that from an array list, let's say, for example. So if you do that, yes, that will end up in a concurrent modification exception, because you are already having an iterator, you are looping through that object, someone is using that, and if you want to delete it inside the loop, yes, you will get a concurrent modification exception, right? So because it is trying to do multiple things at the same time, that is what is called multi-threading. It's not sequential, it's multi-threading. So a new thread is spawned out. When I say T1.start, there is a separate process that is getting started. So that will run on its own. And here you have the system mode getting printed. So this is not going to wait.
Okay. So every time I run this program, the same output, am I going to get the same output?
Yes. Yes.
So it means that one thread is actually doing that run method, and the other is actually trying to print the SOP.
Yes. Yes, that's why like you have, that's why I mentioned it as T1, T2. So T1 is one thread, T2 is another thread. Though we are starting T2 from T1's run method, still T1 is also running.
Okay.
So two different processes are running at the same time. One process from the T1 is printing the state of T1 here, runnable, right? The second line is printed. At the same time, it also, the run is also, getting executed at the same time. And that is creating all these objects. And before even printing the very first line, like while starting T2, before even doing that, your runnable print, this one line of code is being printed, correct?
Okay, got it. So before even starting the thread 2, it is actually the T1 thread status is updated as runnable.
One second. For int I equal to 0, I less than, let's say 100, I plus. All right. So I'll just say current iteration. Yeah, see I. All right. So now we have a loop. Okay. See the thread how it runs. See T2, T1 was started, correct?
Okay.
And then T1 went into runnable. So when it goes to runnable, when I say T1.start, correct?
Okay.
Right. So T1 started and it showed the status as runnable immediately, because this thread is also running.
Okay.
Right. This thread is running and the iteration is also getting printed. Right. See that the little time, like the microseconds or the nanoseconds of the time, the difference between initiating T1 and T2, see the loop was still running till 40 iterations it was running. T2 was initiated when it was in the 40th iteration maybe. So this random thing might be there, because like not every time you the T2 will start after 40th iteration. It can be at the 30th iteration, or can be 30, or can be 50, 60 even. So the time taken to initiate this new thread by the JVM might differ. So the iteration may not be always 40 after which the T2 starts. It can be different. But if you see, I put this one in one method of T1, right? And this one is T2 and getting initiated, and T2 is going into runnable. And if you see the time gap within which the processor was utilized to print 4 more iterations. See, 2 different threads are running in parallel. Now you understand?
Yeah, now I understand. Suppose if the for loop is before the SOP?
Before this one?
Yeah.
Yeah, so it will still start printing the for loop. And after printing, completing the for loop, it will come to sysout, which means like only after 100 iterations, it will come to T1 runnable state, or maybe by that time it would have gone to terminated state even. So who knows? So, but the other thing is here, if you go and print for 100 iterations, this 100 iterations will still go on. At the same time, you will have the new thread created and it turns to runnable. This one will still be running, but the second state, I mean, T1 runnable will not print unless all the 100 loops are executed.
Okay. So T1 will wait for the loop to get completed.
Not waiting. Yeah, obviously, like this is one block of code which is synchronized. Synchronized means like sequential execution. So if you finish up 100 loop, only then it will go to the next line. Not like every line of code is going to be like threaded out and spawned. So this block of code will run sequentially. But before even printing this, T1 runnable, all the 100 will be printed. Fine. Within this 100 printing statements, there could be randomly possible that a state new and runnable will print somewhere. I'll show you the result. Okay, save and run. And if you see here, T1 started, like I said, right? So see where T1 runnable or T1 the execution finished up. See T1 terminated because 100 loops have gone. 100 loops have gone. By the time, like I said, it would have gone to terminated state, right? So there is nothing to do in the thread, correct?
So now it is actually what I expected as come as the result.
Okay. Okay.
What I thought was like after calling the run method. So I thought T2 has to start and then the runnable has to get printed. And after that only the T1 should get terminated. That's what I thought. So now it is actually executing sequentially.
Yes, yes. So this is what it is. This sequential execution will happen like this. You put it back like here. See, we can just say that the random number that I was saying, right? So remember the last time it was printing at iteration 40, right? See here,
Yes.
T2 started. It is only at 38, right? Run again and see the execution might have started at 50. See?
Okay.
So that difference will be there. That random like memory allocation will be there. Not sure, you cannot be very sure that this is the iteration number within this time seconds that the second thread will finish its execution or create object instantiation will happen. Nothing like that. It's going to be random because two different threads started. When the memory is available, it's going to do it. Unless the memory is not available, so it is going to continue with whatever it was doing.
So how is it decided like sequential and it is not sequential?
How it is decided, not sequential or sequential in the sense, man?
Like when the for loop was before the SOP, it is like sequentially it is getting printed. So
even after this sysout, you are having it sequentially only. So the first thing that it is doing is it will print the system out like runnable, and then it comes to the loop. There is no missing in the sequence, correct? So it prints the runnable state, and then it will print
before even printing the T2 state, it is the T1 state is like printed.
Yes, because we call the T1.start, right? We call the T1.start. The next line of code that will execute is T1 get state. So this is the process for this thread, right? So this method is sequentially getting executed. But T1.start is called what will happen when you call T1.start. So we are going to go here and say new object. So the memory has to allocate, the state runner has to create an object for it. Then the new thread has to be assigned. And then you are passing on the state runner object. Then you are coming to print. So this is going to take a little time, few milliseconds, right? Within that, what happens here is it will print the start. I mean, like it executed the start. So it will go on for the next line of code, that is system out.
Okay. So before the for loop, the 100 iteration is getting over. The T2 is completed, and after that we are getting the T1 state. If the for loop
Yes.
is before the SOP.
Yes, because the time taken for 100 iterations to print is less than is less than the time taken for T2 to complete. So which means like T2 is completed, sorry, more than the T2 time. So T2 is completed until it goes on to print 100 iterations. Then it tries to print the 100, I mean like status. During the time, the thread is all dead because run is already finished.
Okay, now I understood very clearly. Thank you.
Sure. So hope you're good with the different states now, right?
Yes.
New, runnable, and terminated. All right.
You didn't explain the code which is
I'm coming to sleep. I'm coming to the sleep mode. Okay. Yeah. So sorry. I'm sorry, got a little disturbance in the mobile. Yeah, sorry. Yeah, so for now, you're clear with the new status, runnable, and terminator, correct? So now we will move on to the next state that will be thread.sleep. So why
one more
we...
question is that where the terminated thread is, I mean, your that terminated status is actually in the method, which is, yes, in the class state runner. So how this is called, when this is called in that program execution? Because we are getting a T1 terminated, right?
See, when you create a state runner object, yes. So if you see here, there is a state runner object that is created in the run method.
Okay.
Right. So whenever you create a new object, nothing happens. No change here. After creating an object here, and you pass this object into a thread, a new thread.
Okay.
What will happen? And I say this object is going to be converted into a new thread. Now, where does this execution start?
The reference is passed.
Yeah, go on. Like, what would be the first method that it would call? Run, correct? Okay. Run of state runner, correct? Run method of the state runner, isn't it?
So if we pass the reference and to the new thread.
No. When you create an object, and pass this object into a thread object, when you create a thread and you pass this object into the thread. Okay. So consider this is, becoming a thread now. Now, which will be the very first line when you call T1, T2.start.
Okay.
Now, which one will get T2.start? So T2.start will be moving to run method of
state runner.
Exactly. Run method of state runner. The state runner is created as my object. That is why we are passing it here. So instead of my object, if you pass like this one, what is this? Yeah. So instead of that, if you pass this thread state, so you will have the thread state object created here. And if you call start, again, it will be like an infinite loop inside run itself. So instead, what we are doing is we are calling the state runner, another class, and you are passing it into a new thread. And we said T2.start. When I say T2.start, what happens? I come here and see it is just like simple implementation of thread.sleep. So for 1 second, it is going to sleep. So within that 1 second, what happens?
The T2 will sleep.
Pardon me?
The T2 will sleep.
Exactly.
Okay.
So T2 goes on sleep. So we'll just put, instead of T1, we'll put T2. Right? So T2 is not getting passed anywhere. 1 second. Okay, so T2, we did not pass it on any thread state. All right. So for now, we are only passing T1. So I'll just show you that. Okay. So the state of the thread that we are trying to print here is it's a thread state object that we created, and this thread state object is only here, T1. All right. So this is the total object that I'm trying to pass on. And what happens here is, instead of this thread state object, if you want to pass on okay, so we are printing state here. We can't change it. Fine. So here we have T2 new thread, and new thread we have passed on a state runner. Okay, so we can't change that. Fine. So this is a little tight coupled with the T1. So understand that the state is going to be printed only for T1. So we are calling thread.sleep for the current thread. Correct? Current thread is T2. This run method will go in for T2 while it is sleeping. While it is sleeping, what happens to T1? T1 dot get state. So that is what our intention is here. So instead of printing it as 1 second, make it like 10 microseconds or milliseconds, sorry. And then we'll start running this. And if you see, the state of the thread is still like less than 10. Okay, we need to reduce it further. Make it like 5 maybe. And that doesn't even run for 5 milliseconds. Yes, it always goes to terminated. So like we need to put some condition that would make it more longer than this 1 second or 5 milliseconds or whatever. So if you put such a condition that it takes a little time over there, so then obviously you will see the state different. Like because T1 is already completed, it always shows terminated. So if this T2 instead 1000 milliseconds, it is sleeping, right? So if T1 is crossing that time, like the processing of this main method, if it is crossing that time, so there is some logic here. Let's say it takes like 2 minutes to run. If you put one millisecond or 1 second of sleep here, then the thread state will not be terminated. It will be like running, not runnable, running.
Okay.
You understand the time lag, right? So I have put 1 second of sleep for T2. Okay. So while T2 is sleeping, I'm trying to get the state of T1. Okay, because the code logic I wrote here is very simple. It doesn't even take 1 second to process all this. Okay. Right. Imagine there is a business logic here that is going to take like more than 1 second, or like, let's say 5 seconds. This sleep is going to be happening for 1 second of T2. So the T1 is taking 5 seconds to complete. During this execution, if you put T1.get state, it will print you running, not runnable.
Okay, running. Okay.
Running. So that will be the next state. So new, runnable, running. So that is what I was explaining in the thread, right? So from runnable, the new, then it will come to runnable. From here, it will go to running.
Okay, after running, then it is terminated.
Exactly, it is terminated. So if there is nothing like waiting or sleeping status, so then it goes into terminated. So the wait, yes, we can just try on a time to wait, like thread.sleep, right? So that we can do. But blocked, and also we need to ensure like there is some system resource that is blocking it, and it is not getting into that particular state. Right? Hope you understand that now, ma'am.
Yes, Kannan. Thank you so much.
So now, the next one would be to go into. So you're understanding different states of the things, right? So sleep and running, runnable, new, terminated, All the 5? Are you good? Shall we move to the next example?
Yes, Kannan.
Sure. Thanks. I'll show you 2 short or very small examples for 2 different things. So the first one would be to have like a thread pool, and the second one is to have a thread group. Okay, so we will go through a thread group and thread pool in a very short explanation, and then we will move on to one of the most important part of this multi-threading. I'll show a real-time example. So now what happens, let me create a class. Okay, so let's call it as a thread group and include a main method, and then here we are ready. All right, so we have the thread group, and what are we supposed to do when we want to convert this into a thread? Can you please explain?
Implements runnable.
Exactly. So you can use implements, runnable, or extends class. It's better to always go for the runnable interface, which will give you an extra, kind of a hierarchy that you can add into, which means like you can have one more parent class by having another extends. So if you are putting thread group and implements runnable interface, add an implemented method, and that is going to be your run, right? So we are going to just do some sys out here. Okay, right, let's keep it that way, and we'll start typing in here something, and then that would be like we'll create an object, thread group tg equal to tg equal to new of thread group. All right, so I created an object for this class, right? So now what I'm going to do is I'm going to define different threads, and I'm going to group them. So t1 dot new thread group, and we can provide it with a name like a parent thread group, right?
Without even SOP, can we print?
Pardon, ma'am. No, SOP is nothing, like we haven't given anything. So we'll just change maybe. That is the reason. Like no, without even anything like system out can still prevail. This one is not a print. Like this one, I'm creating an object for the thread group, and I'm trying to provide a kind of a what do you call a constructor variable. So that is what it is, right? So you have to you have to think about like passing some variable while creating an object itself. You get that? Right,
Okay,
so,
passing a string.
like a constructor variable. Yeah, passing a string to a constructor, right? So I'm going to create T1 thread group demo. No, this is not thread group. This is thread group demo, and there we have thread group demo. Rename the file. There we are. Let's go and create a thread group. All right, so this one would be T1 thread T1 TG. It's going to be TG thread group. Let's call it as thread group. Okay, TG. We'll call it this one as run object. Okay, fine. So what I'm doing here is I'm creating an object for this class. All right. So, and then I'm trying to create a thread group. All right. So when I create a thread group, what happens? This is going to be the name of this process or the complete list of threads that I'm going to create now. So now what I would do is, so T1, so it's a new thread. So you can provide it with something, so which can be like a thread group, right? And then you can just have like a run object. So that is going to be your thread group. And you can name this thread. What is the name of the thread? It can be thread.1, right? So then you can just go in and say thread.start, right? Thread. Just create one more. So that's going to be new thread. All right. So here we have again the same thread group into the same thread group into the same object, and you name it as 2 and T2 dot start. Right now, I'm going into another thread that is T3. Same thing. We'll just copy this. Yeah, so call it T3 dot start EG, and this is going to be 3. All right. So now what I'm going to do is I'm just going to simply make a sys out here and then say thread name. So which can be like a TG dot get name. So that would be the group name, complete group name. So you can just say TG dot list. Now the thread is all ready. So to print. So now this is done. What are we going to do in the run method? So we'll just put a simple sys out. What happened? I'm sorry. So we'll just put a sys out here. And so here we will just print the name of current thread. All right. So now I would start and then say thread dot current thread. Okay. Current thread dot, and then I can just get the name. Fine. So if you start executing this, you see the thread group. What I did, I'm creating a new thread group, correct? So the thread group name is getting printed, saying like get name is like whatever I printed, parent thread group. Then I started T1 dot start, T2, T3 start. So all the three are started. As soon as we start, what happens? It will come to run, correct? So it comes to the run and prints name of the current thread is 1, 2, and 3, whatever we named it here. And then, so what happens is like it goes back and tries to print or get the list of the thread group. So which is going to be like a complete list of thread group. So wherein like it prints out your object, like the name of the thread, the values like the parent thread group, the name of whatever we are passed on, the object that is available. So all that will be provided when you say tg.list. So
What
that is
is
the
that
difference.
file? What is that file?
So this is going to be a random number that it provides for your thread object, the runnable object that you are providing. So the run thread group demo object that you're creating, right? So that's going to be like different. It's going to be like kind of an address. That's it.
Okay.
So these three, whatever we are passing here, so that is what it is. But the object reference, because it's the same object that we are referring, so it is going to have the same value, obviously. So you understand why it is the same number in all the three places, right?
Sorry. Can you tell once more?
Okay. See, when you say string, yes, sorry, name equal to rice. Okay. String name 1 equal to nothing. String name 2 equal to rise, name1 equal to rise. All right. So now tell me, in this 4 lines of code, this 4 lines of code, how many objects have I created? Sorry, how many objects do you think the JVM is getting memory for?
Four objects.
4 objects.
Yeah.
Okay, sure. So you need to understand the object creation in the JVM. See, string is called an immutable object, right?
Yes.
You know why?
Once it is created, suppose if I am modifying the value, it will again create a new object instead of editing in the existing object.
Right. So far clear. So string name1 equal to empty, and then name1 equal to rise. So I changed from empty to rise, correct? So now whatever you said, this empty is not getting changed. Rise is a new object, isn't it?
Yes.
Okay. So internally what happens? So when I call string name equal to rise, a new object is created, new string object is created with a value rise, R-I-S-E. Okay. So
Okay.
name1, when I create an empty like this, so far there is no empty. So then it will create one more object, something like empty, and it will be having a reference name1. That's it. Now
Okay.
I'm going to name2. I'm creating another third string. I'm trying to create a third string name2 with rise. Now what happens, the reference is created as name2. There is no new object created for rise. The name2 will point to rise,
Okay.
name, the value of this one, the object of this one. Again,
Okay.
name1, when I change it to rise, empty is discarded, and you are just updating name1 referring to the object that is created first time. Okay.
So it
So
means
if you
the object is not created.
no object is created. There's no new object. That's only new reference. That two new reference is already there. Like name1, the reference is there. Object is there. All we are going to do is point name1 to rise. That's it. And no new object.
So totally 3 objects.
Totally 2. Rise is one object you created, and there is empty. This is second object. Third object, when name2 is given a value like rise, it will point name2 to here. No new object here. This is not a new object. It is going to point to this one. And similarly, when I say name1 equal to rise, it is going to point to this one.
Okay.
Now what happens after this line? If there is no need for this empty object anywhere in the list of lines of code, let's say here, this ends my code execution. Let's say, for example, the compiler doesn't find any use for this empty object. You know what happens? It gets garbage collected.
Okay.
So henceforth, after this line of code, out of these 4 lines, how many objects do you feel after garbage collection?
2.
1. If garbage collection happens, this will also go. Empty will also go out.
Yeah, one.
After garbage collection, after this line, if a garbage collector optimally executed and removed this empty, then printing these 2 lines, right? So let's say our code ends here, like line number 29. So till that time, you only have 1 object with 4 or 3 different references, right? Name1 and name2, 3 different references, 1 object. This empty is removed, garbage collected. But out of these 4 lines, the number of objects created is only just 2.
Okay.
Clear? So the same thing applies here. So when I say T1 is a new object, T2 is new object, T3 is new object, what I'm passing here is a run object, which is a thread group demo. I didn't change anything. It's the same memory object that is already available, right? So then what would be the value that you can expect in all 3 different threads? The same object, correct?
Okay.
Now you understand this?
Yeah. So parent thread group is the
Thread group demo object, exactly. No, parent thread group is going to be same. This string is going to be same.
The
right?
string. I'm talking about
5.
string.
Yeah,
without
that is
the-
also the same. Exactly. So that is also the same way, same mechanism. And
Since
similarly,
the
this
string name is same, we get the same reference.
exactly.
Okay.
Fine. So far clear. So this is the idea of thread group. So what it is going to do is we are going to group the threads into simple object, like one object that is going to be thread group demo. If you want to do anything over one place, and then you want to segregate or give it to 3 different threads at the same time, or you want to run 3 different threads under one group, you want to group, and then say this is some process, and you want to backtrace it, like what is this process going to do. Let's say processing loan. So it doesn't finish up with one single process, right? So processing loan is not just simple. You have to verify documents, you have to verify the account numbers, do a background check on the applicant, and all that happens, right? So you can call that like different threads, and all that thread is kind of a loan processing thread group.
Okay.
Okay, so the loan processing is one, and then under it, you can call it as document processing. The two can be like background verification, criminal verification, something like that. And 3 can be something like a CIBIL score check, or like his credential scores check. So something like that. So all 3 different things can happen at the same time, but all that point to one thing called loan processing for a single user or a single loan applicant. So that is the ultimate goal here. So to just have 3 different things happening at the same time, but under one tree. Ultimate result I needed under one grouping. That's parent thread group.
Okay.
Okay, fine. So let's come to the last one. So I understand, like, I might be trying to give more practical example, but might be still abstract. Let me know if you still are not able to understand this concept. We will move on to the next one. So that is going to be another kind of mechanism under threads. So that is thread pooling. So pooling is different from grouping in the way that when the grouping is done on different threads, let's say you create 5 threads or 10 threads, you can group them under one tree and then use it. And once everything is done, you are done. The threads are all over. It is terminated. Everything is done. But let's say, for example, if you want to use the threads again from the beginning, so what you can do is you can introduce something called the thread pool. So what we are going to do here is, so we are going to create a thread pool implementation. So this is much important because the pooling concept is available in different things in Java, right? So if you go into the JDBC connections, there will be a JDBC pool. If you go for JSP servlets, the advanced concepts and all, so you will still feel like you have some pooling concept there, wherein like you will do session management, you will do object management, the servlet container. So when you say servlets, so the servlet container will handle all the object created. So it will have that init service destroy life cycle through which it has to follow through. Everything is much similar to thread. The reason why I'm saying similar to thread, because the ultimate infrastructure, the architecture behind a thread or a thread pool or a JDBC pool or a servlet pool, the servlet containers, or a bean container under application context under Spring, everything has this basic infrastructure of having a pooled concept. Pool is nothing but it's not going to take more time to instantiate new objects every time, but rather what it's going to do is it is trying to flush out and keep a fresh copy of that object and then try to use that object again, rather than trying to allocate memory over time for new requests that are coming in. Right. So with that said, like we'll just see a very simple implementation of this one. So what we are going to do here is we are going to leverage something called an executor. So this executor is going to help us to create a kind of a thread pool implementation. So you need to understand what an executor is. I'll just give you a simple example, and then we will move on to some important stuff. So executor. So what we can do here is you can just say executors. So executors. And then like, let's say we'll fix it to new. So there are different ways, like, you can say cached thread pools, you can say fixed thread pool. So you can just define the way that you want, right? So the cached thread pool is nothing but it's going to have some cache, which means like it's going to have some memory, pack memory, a dirty memory that's going to retain some values. Let's say I'm just going in for some fixed memory. Okay, sorry, fixed threads. So let's remove this, and then we'll just make it like 10 threads, right? So we'll just create 10 threads at the same time, and then we'll import everything. Executor is now ready. So now you are creating 10 different threads. Now what we are going to do? So here we are going to do, yeah, so here, before even going to the thread pool, we need to create the actual thread itself. So let's call a worker thread. All right, so this is going to be like a class that is going to become a thread. So now can you please tell me what should I do to in order to convert this to a thread? Hello, anyone there? Am I audible?
Yes, you are audible, Kannan.
Yeah, thanks, Nandini. So yeah, can you please let me know how you can convert this to thread? Okay, so fine. I'll just say you have to use implements runnable. All right. So what we are going to do here is we are just going to have a message. So that is going to be so that's going to be a string message. So we can use a kind of a constructor for this class, and we can just go ahead and create a constructor for this, and that is going to be worker thread. And so yeah, so we can just go ahead and then there you go, and then string, and then you can just message like no, paste this message, and then use a class level variable that is string message. All right, so now we are passing a string message through the constructor and assigning it to the class level variable. So now if you see, like I said, implements runnable, then we have to go in for the unimplemented method, that is run. Now the run method is getting ready. So what we have to do is just remove this, and then we'll just go in for a simple sys out and then try to explain this. So now what I'm going to do is I'm just going to say thread dot current thread. So thread dot current thread dot get name. So because like we have so many different threads there, so we will just go on and then say thread message, right? So the thread message or the thread, let's say, yeah, so the message is what we pass. All right, so the thread message will be something like this, and you can pass on the actual message that I'm trying to have now. So right, then what I could do here, I could just create one more method, which I could say public void process message. I'm going to do something here. So what is that? Is that I'm going to use a try catch block, catch exception, right? So this is going to go in for a sleep. So the process is nothing but making it sleep for maybe just 1 second. So each of them is going to go in for a sleep for 1 second, or you can just make it like 2 seconds, right? So 2 seconds, this thread is going to, going to go in for a sleep. All right. So now what happens? So I can just call in process message and then done. Then Yeah, all right. So now here, thread dot get, sorry, current thread dot get name ends. So here you end the thread, right? So this is going to be like a run method, and you're going to have another process message method. So that is going to help you in printing this. Now everything is ready. Now let's go back to the actual main method. So wherein the process execution is still waiting. So now here we are, and we will just go in for so int I, sorry, int I equal to 0, I less than I less than, so we create a 10, right? So we'll just go in for 10, right? I plus plus, all right. So here are the condition. So for each of this condition, I'm going to call the runnable condition of the worker thread. And then what I'm going to do is new worker thread. All right. So, and let's pass on the I. Okay, I'll just make it as integer then. I dot toString. So the loop structure itself, I'm just passing the loop number into the executor class, and now the executor is ready to just have executor, not await. Sorry, it just came in. So executor dot execute. So once you put the execute, what is that? So we are going to pass in the runnable object here. That's it, done. So now if you see here, I'm using an executor class, and this executor is going to create a set of 10 threads at the same time. So initially, as soon as this line of code executes, you will have 10 threads ready, which means like runnable stage. So then what happens? So I'm creating a new worker thread. The worker thread is nothing but the object that the class that we created. We are creating an object for that, and the constructor is going to take some message. And what is that message? We don't have any message. So we are just going to put the same number of this loop into that one. All right. So with that said, we are good with running this code. Just run and see. If you see the pool, so the pool that it created is so and so. The first one is the message is 1. It run the thread 2 because like based on index, it will be like a difference will be in 1 value, right? So the loop that we started is on the 0 index. So it will just print in from 2. So the thread 2 started and the message was 1, which was getting printed from here. All right. So similarly, you get process message so many times, and every time it goes on for 2 seconds of sleep. And that is why, like, it did not end abruptly as soon as it started, but ends slowly. If you see 10 finished up here, but after finishing up that print, it went in for 2 seconds of sleep, correct? Because we called process message. So it went in for 2 seconds of sleep, and before even ending the 10th thread. So that's why we see that 10th thread. So that will be like ending after 2 seconds. Similarly, this thread 3, it started, executed, waited for, slept for 2 seconds, and then woke up and it got terminated. All right. So this is something like, a kind of a thread pool. What happens here is that the thread is not dead yet. It can go on, it will come back into the thread pool, and you will still have this executor alive. So that is the difference between using a normal thread group and thread pool. So thread pools, the thread will not die off. The thread says ends, but the state of the thread will not be end. It will still go back into the thread pool itself. Clear so far?
Okay.
Yes, no? See, there is nothing difference between thread group and thread pool. Not just to say like a major difference. Group is something you have so many threads running at the same time, finished off, then the thread state is terminated. But here, the executor will execute the thread, the worker thread, whatever we created. And after finishing the execution, when it says ends, the life cycle of that thread is not going to have terminated state at all. So it is going to go back into the live status. If you see this in my like console, see this, it is still running, right? So it is not terminated. Which means those threads are alive. They are waiting for some other new task to come in. But if you see, I'll remove this and then go back to thread group demo and then unpack this and then run this class. It did run, it put all the thread group, but if you see the status here, terminate, it is already terminated because all the threads are run. The execution is closed. Your application is all done and it closed. But if you go for the other one, the thread pool, and try to run this one, thread pool, see this, like this red icon, it is not there, right? So which means like process has been completed, but thread pool, you see that difference. It is still running. See this, all threads are completed and everything is process done. But if you see this icon here, it is still running. So it is using the memory program. All lines of code are done, like it still runs because the thread pool is alive, right? So you understand the difference now?
Yes, we understood. Where we can use this one, Kannan, because it is using our memory.
Yeah, okay. So that's where I'll try to show a real time scenario, real example. So you will see the difference of, the normal code and the actual code. So this is just going to be like a simple example, right? So you are just seeing what is a thread pool and we are just seeing this. But what is the purpose of having executor service? I'll show you a real-time example that's going to take maybe half an hour or even more. But would you be able to follow through? Like, will you be able to sit up like for the next half an hour?
Okay.
I'm done with my things on multi-threading. So there is nothing additional I have to I have in my plate for explanations. So what I would like to say is like this executors. I would like to show a real-time example. So do you want to follow through, like, or do you want to have like an assignment? If you want, I can just clarify questions and proceed and give you the sample snippet. You can run and understand. Or if you want me to explain the code, I can just show and explain the code to you.
Just show and explain.
Okay, fine. Okay, fine. So that's going to be taking a while. So that's a big scenario, right? So what we are going to do is, yeah. So what you're going to do is, so we are going to have a big application development. So in order to do that, what we will do, we will just go in for a new project, or maybe, so I'm going to delete all this, all right? Done. So here we have a package. We'll delete this one also, right? So, right. I'm going to create a class that is going to be com dot we'll call this as com dot rise dot application. All right. Oh, sorry, I created a class. I need a package. Sorry. Com dot rise dot application All right. And then we have a class. So that is going to be application.java. All right. So what I'm going to do here is I'm going to be the manager or maybe CEO of this application called Rise. And Rise is going to do what? It's going to do a food delivery app. So we are going to handle some orders and we are going to deliver them based on certain conditions. Okay. Now what happens? So the first thing I would like to see is I open my business. My app is available, which is a thread. Under that, I'm going to have login. I'm going to have registry done. All right. And then what happens once I log in or register, the next step I could do is like maybe order food or check status of my food, status of food. I mean, status of order, let's say. Why? Okay, status of order. And the third one can be history of orders. If time permits, I will explain you all the three and how it is getting updated and all. If not, you can just take it like an assignment and try to complete yourself. I'll try to explain as much as possible in this entire chain. Okay. So once you understand how this thread is working, so everybody is going to be like a thread in this step. Okay. The customer is a thread. The CEO is a thread. The CEO, which is myself, I'm going to be looking on the console on what is happening in my business. So I am a thread. The customer is a thread. Okay. And the restaurant is a thread. And a vendor is a thread. And a delivery guy is a thread. Okay. Now what happens is the CEO opens the application. So he is watching that. So the console that is going to put up all the display, that's going to be a thread. That is the CEO now. Now what happens? The CEO is giving you options, login, registry. What happens? The customer will come in and he will log in or register his name. Once his name is registered, he will just go in for a login maybe, and then he will order a food, maybe like some dish. And once the order is put, now what happens? The restaurant, which is a thread, as soon as I create or put an order, the restaurant is going to start its work. Correct? The restaurant will create some dish for me. It's going to take some time, but however, he's going to prepare it for me fresh. So he's going to take a few minutes and then he will prepare it. So the next step is to get that delivered, correct? So to deliver that, what happens? The delivery guy has to wait for the dish to be prepared. And once it is ready for delivery, only then the guy can pick it up and deliver it to you on your doorstep. Correct? So then is that going to happen within like just like that in a magic? No, it's going to take some time for the delivery guy also, right? So he is also going to take some time and then deliver to you. So all this are going to happen. And in the meanwhile, the status of the order is going to get changed. So as soon as you say, yeah, I need dish one. So that status of the order is going to get changed into ordered. The next state, as soon as the restaurant completes its work, it will be ready for pickup. And as soon as the delivery guy picks it up, the status of that will be on its way. And finally, when the delivery is done by the final thread, that is the delivery thread, the delivery guy thread, it is going to be delivered. So these are the different status of this food delivery that we are going to look for now, right? So this is a big example. I'm not sure like we'll be able to finish up within half an hour even. So I'll just try to explain it and give it to you. If we are not finishing all the things completely today, please try to do it like an assignment and, for yourself, self-study, like, you can try to finish that up. So I'll give you a heads up. I'll give you a thought about how this thread is working for sure. And from that, you can pick it up. All right. So, right. So we have an application.java, correct? Right. Then what are the other things we need? So this is like a real-time application development. So please understand and ask me any question that you don't understand anywhere here. So the packages, the names that I provide here will be like the real-time applications itself. Okay. So I created a package like a COM application that's going to start the application. Then other than that, I need another package. So where I'm going to have different DTOs. So the DTO are nothing but data transfer objects. Nothing very fancy about this. It's just like going to have some private variables, and it is going to have some getters and setters. That's it, right? So the first thing I need is a customer. And even before going that, the customer is going to go in for a new order, right? So I need an order.java. So this is the first step. I'm going in, I'm just preparing it on the fly. Okay, so I'm just going to have an order. So this order is going to have a private integer that is going to be your order ID, and then your private string, and that is going to be your item name or the food name, whatever. And then you can have the private date. So that is going to be your delivery time. All right. And then ultimately you will have one more thing, the important one, and that is rate. All right. So I have rating, I have this, I have that, whatever. And then util date, because date is not part of the data type here. So everything is ready. What I'm going to do is I'm going to go to source, generate getter setters for all the 4 variables. Yes, my order DTO is ready, correct? Once the order DTO is ready, next one, who is going to do an order? That's going to be a customer. So here we are. So we are into the customer object. So what is that going to happen here? So this guy is going to have customer name, all right, and then private let's consider it as integer for now. Sorry, integer for now, and so that is going to be your cust ID. All right, and then what else is going to have? We are going to track his orders. So that is going to be based on his order, right? All right. So here we are with the customer who's going to have his name. You can add on if you feel like adding his mail ID, phone number, everything, you can try everything. But for now, I'm just sticking to customer ID and customer name, which is important for me, and orders, which I'm going to insert. All right. So this is now ready. So you have customer, you have order. So who is going to prepare this? So we are going to have someone called the restaurant for the delivery guy, correct? So the restaurant. So we will just create. So what is going to do? So first, initially, we will just create it like a kind of a restaurant. Okay. We'll just go in for another package. So that is going to be com dot rice dot service. Okay. So within the service, what are the 2 different service? I mean, basically 2 different service. So we will just go in for the not customer service. I'm sorry. So this is supposed to be restaurant service. All right. So the restaurant service is going to handle what? So I'm going to have a public void, let's say process food. All right. So he's going to process my order and then provide me with what I need. Okay. Now what I'm going to do, I'm going to have a try. I'm going to have a catch. All right. So here we go. Here we have an exception E. That's fine. All right. So now let's just print preparing food. So the first step, as soon as the order is received, is going to say preparing food. All right. So then what we'll do, we'll just make this the food preparation. Let's say it's going to take 5 seconds. Right. So the next step, what is it going to do? So the food is being prepared. Packing order. All right. And again, packing is going to take some time. So just have 5 seconds. And then ultimately, we are going to say package ready for pickup. All right. So we prepared some food, we have packed it, prepared it, and then what you have to do, send the delivery guy a notification saying, hey, food is ready, please go and deliver it, right? So yeah, so this is done. And what we are going to have, the next service is going to be the delivery service. All right. So yeah, and before even going that, one important thing to do here with respect to restaurant. So see, a processing of this food, or maybe like taking an order, do you think like someone, like say you order for a dish and someone puts another order for the same dish, maybe, do you think half the way this guy is going to include our, the second order? No, he's going to finish the first order, then take the next order for preparation, correct? So that is, how do you pronounce it in Java? Like it is called synchronized. All right. You are just making it synchronized to ensure that this food is prepared properly before even taking the next order. All right. So it is not like you suddenly, like someone else orders something and then he will put the same dish for halfway cooked into your dish, correct? So it's not going to happen. So you'll finish your dish and then go for the next one. So that's what it is. So yes, right. Next one. So the delivery service. So the same thing is going to happen here. So we will just make it public. And so he's going to be like you're going to be a priority customer. So you're given a individual delivery. So he's only going to pick up your order. And if there is so if there is any other order, he's not going to pick it up. So what we are going to do here is we are just going to see how this guy is picking it up. Now the same thing happens here. You have a try. All right. So you have a catch. All right. And there goes exception block, because we are using a wait. So what happens here? So this is out now. So pick the package. So that will be the first step. All right. So he's going to take another 5 seconds, not more than that. Okay. So here, what he's going to do, reach the custom home, customer location, maybe. Okay. He reached a customer location. Now he has to get out from his bike and then come back and say, madam or sir, your delivery. That is will be doorbell rings. Okay. No. All right. So now, before when he gets to the customer's door from his bike, another 5 seconds. And just randomly putting up numbers. Okay. So please. Done. After he is delivering his order, he has to notify to the CEO, which is myself, and he's going to say, I'm ready to pick up the next delivery, because he's done. His work is over. All right. That's it. Simple as that. So we have two different services, delivery service and restaurant service. And then you have order and you have customer, and then you have other things. Now we are coming down to one of the most important thing, that is going to be our event listener, right? So what we are going to do is we are just going to create an event listener. This might be a little vague, but please bear with me. You need the event listener. If you don't understand event listener now, well, that's okay. But you can try to learn what is an event listener in the due course of time. Okay, so I'm just going to create a new extended mechanism that is going to be my event listener. All right. So far clear. So am I too fast? Are you able to follow?
Yes, Kannan, able to follow.
So what I'm going to do is I'm just going to create an event listener that is going to be like, let's create a hash map. All right. So I need certain things. So I'm just imagining certain things, and then I will go ahead and create something. So we'll need action. Okay. I'll explain you what this event listener is all about. So we are going to continuously listen. So when the business is open, what we have to do is we have to continuously listen to the inputs from the customer, whether it's a order or a complaint or whatever. So we want something, right? Listener action. So I'll just create something like action. Right, sorry. Yeah, correct. Even listener dot action, and then there you go. So we'll just come back to that. All right. So then what we need is a continuous listening capacity to one of the input module, that is scanner. Then the action is nothing but I'll just name it default action. All right. So we are just going to create an event listener. So that is going to have an action, item that is going to be fulfilled. And then we can have you can scanner. So scanner should be there. Not AWT. You be quiet for some time, and then we will just go in what is this action is all about. Okay, fine. So there we have a event listener. So in this event listener, what we are going to do is we are just going to have a public void is fine. Add action. So this add action, what is going to do is just going to do this is going to take a string message and then action. I'll tell you what this action is in the end. So answers and, okay, value answers not put, and then message to lowercase. We can do that. Yeah. Okay, fine. So we have an action. Then, so what we are going to do, so this is going to be an add action. So this is where the real thing comes into picture, the public event listener. All right. So this event listener is going to pitch in with a scanner item. And so this is going to have action default action. So that is what the event listener is going to do. It is going to take up an event listener, and this is a constructor. So you have this scanner equal to scanner, and then you can just go in for this dot default action equal to order. Okay, so this dot default action. So let's consider a condition. So I'm just creating a daemon thread here. All right. So what this is going to do is it will listen to all the inputs that I could provide. So that is the ultimate aim. So default action. So any of them is null. Any of them is null. Then through new new exception. Will that be okay? values in event listener. All right. So far, good. Okay. So now we have given an add event. Then obviously we will also have remove action. All right. So this remove action is going to have string message, and then what else you can have is like an action, and then we can just say answers. So that's going to be answers. Sorry, no, yeah, it's a remove. So you're just going for answer dot remove. Instead of this, you can just say message from action. So that's going to remove it. All right. So far good. Remove action, and then we are not going to leave it there. You can also have a replace action, wherein the same thing. So we are just going to have string that is going to be message, and then similarly an action that is going to be action object. So what is that going to do? So replace. Okay, so replace is also going to return action object. All right, and then what happens here is return. So we'll just return something. Yeah. And answers dot replace the message and the action. That's it. Okay, so this is going to replace that in the hash collection. That is fine. And ultimately, the last one would be to have listen in new thread public void listen. Okay, so I'm going to put a new listener thread. So I'm just considering this as a thread now. So it's new thread. All right. And then we will have not this. We'll have a new thread object that is going to create. And then we are just going to have a direct public void run from here itself. So public void run, and then you can just call in a listen. What is this listen is going to do? Yes, we will do that. Yeah, thread. So this is where it is finishing it up. So we'll just add t dot start. All right. So thread is started. Now we have to go in for the listener method. So public void listen. So what I'm going to do here is I'm going to continuously watch or continuously listen. This is called polling. It's a polling concept. Polling is like you're just going to continuously listen to some resource, and that resource is going to while true. Yeah. So while continuously listening to some of the events happening, so it will keep doing the same thing. And let's say I'm looking for some user ID. Okay, so if the user ID is being typed in by the user in the console, it takes the input. It doesn't stop there. It again starts listening back. So listening back to what is next. Okay, you're given an input, then what is next? So that is what it is going to do, right? So it is going to replace all, and you can just yeah, you can just remove the empty strings and then replace them with an empty string. And it's not an empty string. Okay, so we'll just put a regex here, and then we'll remove all strings and then put a regex. All right, so that's going to be all. So I'm just putting a regex so that like any invalid input or any string, the input that we are providing. So we are going to put an empty message over there. So finally the message would be message dot trim, and then like, dot to lowercase. Yeah, there we go. So this is all just to make a daemon thread work and help us getting all the inputs. Right, answers dot get message. We are trying to get the message, and so if at all, what I would do, what if the action itself is null, right? So yeah, so then we can just say action equal to default action. So we are just checking if there is any null action being provided by the user, then the default action would be nothing. Like the default action is actually we are already listening back to the code, right? So that is what we are going to do. So then action dot whatever we have provided, or action dot act, and there we go with the line whatever we did. And what is this act is going to do now? So this act is going to help me out while writing a public static interface. So which is going to be an internal mechanism. And so what I'm going to do is I'm just going to have a declaration of void act, and there the action is being passed and the string message. All right. Oh my God, so far so good, no error so far except the event listener. Okay, fine. So let me explain the code. Okay, right. So please listen carefully. So what happens here is that even listener, it should, yeah, there you go. Right. Will remove unwanted inputs. Right. So now what happens here is that I have a method throw new exception. You're not going to throw declaration. Okay, throw. Yes. No, you don't throw new declaration. Then rather, I would just say you can just, for sure you are going to throw something. Then we can just say null pointer. Null pointer exception, please. Yes, there you go. Fine. So what we are going to do here is I'm just going to have an event listener. Event listener is nothing but whatever is happening. So I'm just opening a thread, a daemon kind of thread kind of stuff, and that daemon thread is going to listen to what I'm going to do. So if you see, so this is the constructor for the daemon thread. So what I'm passing here is my scanner and my action. You know a scanner. So have you used a scanner?
Yes.
Yes. So what is the purpose of using a scanner here? I mean, like a scanner in your code?
For getting the input from the user.
Exactly. So what I'm going to do is I'm just going to use my console as an input, right? So the scanner is going to be my the input provider, and then also I'm going to take up a default action. So I'll have an input, and based on that input, I'm going to do some action. What action I'm going to do? That we will decide. So default action is nothing but like the declaration that we are providing here, the default action. All right. So that is going to be an inner interface. So that's a sub interface. All right. So now what we are going to do here is we are going to add few methods like add action, remove action, replace action. So all these are nothing but it is going to put up its values into a hash map that I created as answers. So whatever we are entering over there, so everything will get stored into answers or get removed from the answers. So based on the value that gets into or removed out of this answers, that is what I'm going to listen to. So if you see here, I'm going to listen to the message and try to get the message. And if you see, there is no action. Let's say whatever I entered is not there in my list already. Then I'll return myself to default action. What is the default action? I'll come to that picture into the main application. All right. So for now, we are adding, removing, or just going to listen. All these three are going to be here. So even listener, add and remove. All right. So just give me 5 more minutes. I'll explain you the actual business logic now. So you have customer, you have order, delivery service, restaurant service, and then even listener. So far clear?
Okay.
Oh, you're clear? Doubtful?
No, clear.
Okay. So I'm going to create a hash map. All right. So quickly. So this hash map is going to have an integer. So that is going to take up my user details and then my customer. So who's going to be my customer object. And then I will just go in for customers. Will it be okay to just spend 5 more minutes, please? I'll just explain this basic thing and then you can go ahead for other options, right? Will that be okay?
Yes, Kannan.
Yeah, sure. Thanks. So I'm just creating a hash map. So this hash map is going to be my complete list of what? So complete list of my customers. All right. So the customer is going to have his own customer ID. That is the key. Then my this one. Okay. So I'm just going to have public. And what is this public is all about? I'm going to have public application. So what is this? This is a constructor. So this constructor is going to have an input of hash map. And then there we go. So this dot customers, this dot customers equal to customers. All right. So here we have a object being created. So that's enough. Now what I'm going to do is I'm just going to create public static void main, and then there you go. String, yes, no need to fancy stuff. And then yeah, just going to take a string args. So no need to check fancy stuff. So now I'll just create a new application, and then what we are going to do here is like, yeah, we need new new of hash map. All right. So there you go, new hash map. I passed on some dummy object while the initiation starts, and then here we go, and then we have to go in for a start. So because this is going to be a thread, obviously we are going to do a start. All right. Now, so what is this public start is going to have? So this is the start of our application that is going to print something, and then to go and get something. Welcome to Rice. Okay, the food delivery. All right, and then CISO, and then we are just going to say enter /1 /1 to login. All right. Now what I'm going to do is just put the same thing again, and then say to register. All right. So I'm going to place up 1 to this thing and 2 to register. And this is where our event listener comes into picture. All right. Okay, event listener. I'll just start putting that event equal to a new listener. Okay. So and then I have to pass on 2 things. If you remember, one is my scanner, and the other one is my action. So the new scanner system.in. All right, I'm passing this object, which is the first one. The next one is a new event listener dot action. All right, so we'll just include whatever is there, scanner, and then event listener action. What happened? Okay, I did a spelling mistake here. Event listener. All right, so event listener. Oh, sorry, I'm just pulling it from the actual thing. So this is supposed to be, yeah, that's the event listener. Where is, okay, yeah, I'll just go through it. Maybe like I'm missing out something here. We'll just fine. Event listener should be an action, and we're not here. Event listener. Okay, so we'll just go in for the, okay, fine. So that's going to be event listener. So the event is nothing but public void act. So there we have. So the void act is going to have string option. So whatever option that the user enters. So we are going to have a switch. All right. So the switch is going to have the options. All right. So the option would be something like a case. So because we entered case 1. Okay, so there we go, like sys out, and then say like okay, page. All right, so then, so what I'm going to do is when the new login page appears, new application, so then I'll take the customers, which is the list already available. Customers already available, and dot login. For now, we'll just keep as login. I'll explain you. I mean, like we are going to write the login method. So then we'll just go in for a break, and then we'll just have case. This is number 2. Okay. So I'm just going to have the same thing here. And instead of login, I'm just going to have register page. All right. All right, so we'll just have a little decoration over here, and then we are into register page now. So this is going to have the same thing, new application, whatever. The only thing is, so instead of login, we are going to just have register. All right, so this is going to have a break statement again. Done. So are we going to stop here? No, we'll just one more thing. We'll just go in for option number 3. So that is going to just have new application. Start. All right. So we are just passing the customers back, and then we are having a new application. Then we have the default, nothing. We'll just leave it. All right. So here we have the default action, and then we have sorry, I'm taking more time, but just it's getting over. Just 2 more methods. I'll just finish this up. Okay. So there's going to be event dot add action, right? So on the add action would be, so if I provide the word called, I mean like the word, I'm going to use the stop as the keyword. So when you say stop, so it is going to stop my application. That is the idea here. So event listener dot action again. So what I'm going to do here is, so I'll just open and close and just write a function. So on this event listener and public void act string. Okay, so I'm going to pass this option, whatever that the user typed in, and then so and then here we'll say bye bye. All right. So and then what we are going to do is I'm just going to system dot exit. So that's the keyword that we are going to use, and use 0 to exit out of this system. Application is all done. So now what we are going to do here is we are just going to have two more methods, and then like event dot add action. So add action. So you can just say stop repeating maybe, and then like we can just stop propagation of the same event being used up by the user again and again. So new event listener dot action. All right, so this action is going to have same kind of public void act string option, and we are going to say console error repetition. All right, so that's the end of the event listener. Now what we are going to do is we are just going to have event dot listen in new thread. All right, so we're going to listen to the new thread, and we are opening the continuous while loop now. So this is going to listen now, and then while it is true. So did we do that? No. So while it is true, so what we are going to do is we are going to have a try, and we are going to have a catch, and have an exception E, and then on the try block we are going to say thread dot sleep, and sleep for maybe just once. That's fine. Okay, now comes the actual functionality. So that is going to have a catch block, and that is going to have this one. And yeah, so here we have public void login. So what we are going to do for a login and what we are going to do for register, and that's it, like we are done. So once the user comes in and says login, now what we are going to do, so we will say enter the login ID. All right. So and then like we will just say string login ID equal to new scanner, right? So we'll just go in for system.in. So we are passing it, and then we are passing the next line. So we are going to store that in the next line. So now we'll go for an iterator. All right, so new iterator. So rather than new iterator, what we can do, just customers, we can directly go on customers. So the customer is the map that we created in the beginning, if you remember. So for that, I'm putting an iterator. So that's an entry set. So while the entry set is being created, so the other thing that we could do is like, we can just have a customer object. Because we are going to find in a logged in user. All right. So what we are going to do is we are creating a customer object logged in user, and then we will assign it as null for now. Okay, so util iterator, and we are going to have a null for now, right? So now what we are going to do, we can iterate through the object. So while so customers, so iterator dot has next. So till we loop into the picture. So what we do, map dot entry, and then into the entry. So what we have, so we will just have something like a customer. That's the current customer that we have, right? So we will just typecast into map dot entry, and then so what we are going to do is you're going to typecast the iterator dot next. So the next object, whatever that comes to the picture, so that's going to be there. So we are going to have the string key, and that is going to be customer dot get key. So we are going to get the key and change it to toString and try to compare that. What we are going to do is we are going to put an if condition. So whatever the user tried to use for login, we are going to compare. So that is going to be key dot let's say equal ignore case, and then we are going to pass on login ID. All right. So if the login ID and the login user in the list of maps, if it is matching, then what we do is, so we are just going to say logged in. So whatever here, so logged in user. So logged in user is typecast of customer. So I'm going to typecast the customer as customer dot get value. So from the map, I'm trying to match the user and say, okay, so this guy is already available in the system. So I'm going to let him come into my application. So I'm just saying welcome. I'm just going to say plus logged in user. All right. So this is a customer object. So I'll just say get customer name. So that's going to print my name. All right. So now, so the next one is system out, and then I'm going to give him enter options. All right. So enter options, sys out. So that is going to be A for new order. I'll keep it simple. I don't want to proceed any further. I'll just close it here quickly. Yeah, A for 1 and B for status. B and C, you can fill it up. If you could take it like assignment, I'll just show what A does, and then C for order history, let's say. All right. So now I'm getting this once. I'm just taking the string, and so the user option going to be new scanner. All right. So new scanner is going to be system.in, and then next line. All right. So that's going to be a new system next line. So yeah, so we are done. And then we are going to switch options, whatever that user options. So whatever the user entered, so we are going to switch over that. So I'm just going to put only one switch. So that is going to be case A. All right. So now what I'm going to do is so and say new order created That's it. So I'm just going to stop here, and yeah, and then we'll put a catch block. All right. So here is where our actual execution starts. So here our user has ordered for something, right? Restaurant service. Restaurant. Okay. So restaurant equal to new restaurant service. All right. What happened? Oh, sorry. Okay, so restaurant service and then new restaurant. So this is going to be some kind of a thread. So what I'm going to do is I'm just going to create REST process. So the restaurant process is going to be a new thread. All right. So the new thread is going to have add over. So we'll just create a override the thread object, and then we'll just write it directly here. Public void run. All right. So public void run, and then restaurant dot what is that? Process food. All right. So we are processing the food when the user brings in a new order. So that is going to be it. So where it stops, and then here we can just say rest process dot start and rest process dot join. All right, so we are good with this, and then we will just copy the exact same stuff and then paste it back here. Instead of restaurant service, we are going to have delivery service. All right. So the same thing we will be doing here, new delivery service. So this is going to be delivery. And then instead of rest process, we will just have delivery process. Delivery process is new thread, and new thread. Here we are going to say delivery dot, sorry, delivery dot and pickup. All right, so that is all about the process, and again the delivery that we are going to do. All right, so what we are going to do here is we are just going to say delivery process dot start, and we don't need this one. All right, so here we will just go in for interrupted exception possibly, and then interrupted exception. All right, so this is the thing, like, you know, switch B and C, you can do it later if you wish to. And this is about the login service. So where it ends here. Just one small line of code here just to have the register done, or else we can't test this. So what we are going to do in register is just simple. We are just going to have customer. So new customer, new customer. All right. So the customer is going to be new customer object. And so we have created him, and then we'll have the scanner initiator, and that is going to be first entry, let's say, for example, and then it is going to be new scanner, and then we'll just get the system dot input from wherever we are trying to enter. All right, so here we go. So enter customer name, that's it. I'm terribly sorry, like I'm taking a lot of time, but I'm just trying to complete at least one full loop, which you can understand. So set a customer name. Okay, so customer name, and then you can just say cust entry dot next line. All right, so we are getting that, and then the next one would be enter customer ID or the user ID that you prefer to, and then we are going to do the similar thing here, but the only difference is, if you remember, we set it as integer for the customer ID. So we'll just say set cust ID, which is going to be cust entry, cust entry dot, instead of next int, I'll just replace it here. All right, so we are just getting it, and then so what I'm going to do is customers dot put so new customer dot get cust ID, right, comma new new customer, and then just to understand, customer registration completed, 3 to go to main menu. That ends our application right here. So so let me explain what we have done. All right, so is there any error? Let me process. All right, the same thing, I missed a semicolon. That's a copy paste issue again. Okay, all right, fine. So here we give options, and I give option here, typing mistake again. Okay, fine. So the code is working smooth now. So the executor service, if you remember, like the event listener, whatever we did, so it is going to add an action, remove an action. So that is what we are going to invoke here. So what we are going to do is, so we are going to create a main method, and within the main method, we are just going to have a thread started, and the thread starts, and it will just give you an option like login or register. You can keep logging in and registering your user details. So the 3 is nothing but the default action to go back to the main menu, and 1 and 2 are going to be like diving deep into some functions. One is login function, the other one is a register. So what happens here? So once you enter the login, so it is going to check my hash map. So this hash map I'm going to check and see the entry that we made here, like list of customers. This is going to be our database now. So this customer entry, whatever you have made, we are just going to take the value and see if the user IDs are available in the hash map, the hash next, the iterator that we written. If it is available, if the key ID is matching, then we will say welcome, Mr. So-and-so, whatever name we are registered for. And then we'll have options like A for new order, B for status, and C for history. I wrote only switch case for A for now. So I'm just going to get new order created. And this new order, what it is going to do, it is going to call the restaurant and say there is a new order that from so-and-so customer, and I'm going to run the restaurant service. So if you remember, in the restaurant service, we did like preparing food, packing order, ready for pickup. All right. So once the pickup is ready, and then what we have to do is, should we stop there? We have to join with something else, correct? What is that? That's going to be our delivery service. So the delivery service is going to pick the thread, and wherever they have done, when the package is ready. So we are going to join the line queue, and then we are going to pick up the order, and we are going to deliver it to the customer. And that's what we are going to do. So this customer registry is nothing but we are going to get the scanner inputs from the console, and then we are going to update the hash map. That's it. So I'm going to quickly run this application and show you. So we have food delivery app ready, and then we have 1 to register and 1 to log in, 2 to register. So initially I'll go in for 2. The customer name, I'm just printing my name, that is Kannan, and the customer ID, I'll just give 101, and I'm ready. So registration completed, press 3 to go back to the main menu, right? So I press 3. Now I'm coming back to the main menu. By this time, my hash map is ready. My user registration is already done. So I'll just go in for the login. So the login ID, I am going to put in for 101, which is my enter value, right? So it is going to pick up from a hash map, my value, that is Kannan. So it says, welcome, Kannan. You have order for new options, new order or status or whatever. So I'm going to put a new order. B and C we didn't do, right? So we'll just go in for A. We're just going to test A. I'm entering A. If you see new order created, the food preparation is started in the restaurant, 5 seconds, and then the package order is done. And then what happens? Package is ready for pickup. As soon as it is ready for pickup, you see the other guy, delivery guy started. He picked up the package and reached the customer location. And he is ringing my doorbell and the delivery is completed. Right? So we have two different services. One is delivery and the other one is restaurant. And we have the admission. I've been like the login user, the registration user. And so you have every possible thing of the core business for registration, user ID and delivery of the food. You can go on adding like, additional information about the user, and you can keep, so once this delivery is completed, you can enter, I mean like as soon as the order is created, you can put it up here in the customer DTO, like where the orders list is being already declared, right? So you can enter the value into the orders list, and you can keep creating like, functionalities over and over, whatever real functionalities that you have. You can start over from here and you can create all your, options. So now this is all done. So I can just go back even like, I can just give back the user ID again, and just can go back to the main menu and then log in again, and then again order a food packet, and then it will still continue on. So the thread is not going to stop. This is going to continuously work. If you have multiple systems, multiple applications, or multiple phone devices working, so if you put this up into a thread pool, into a server, it's going to handle multiple operations as such. Just instead of using this hash map here, so just that, you just remove this hash map where I'm updating my username as Kannan and all. So you can just remove this hash map and introduce a database here. And then like instead of this console, this executor listener, whatever, even I mean like executor service. So we can just remove that and add a HTML page or an Android application. And then the core business functionality is going to be the same while taking the delivery service and restaurant service. You can add other things like just rather than giving 5,000 milliseconds every time, what you can do is you can add a list of dishes like dish 1, dish 2, dish 3. So dish 1 is going to take like a half an hour. Dish 2 is going to take 15 minutes for preparation. Dish 3 is going to take like 10 minutes of preparation. Like that, you can give different time that you can push in for wait. And then like, you can really see a full complete food delivery app that you can, generate. All right. So
it was really interesting, Kannan, actually. But as you told, it will be very, it will be nice if we, help us to, if you give this code and if you help us to finish up that code. I mean, whatever the study. So
I'm really glad. I'm really glad that you're interested, ma'am. Like I'll surely zip up all the code snippets. I don't know, like I deleted all the other code. Maybe I'll give this one. Like this code is completely there. I just created this on the screen share, right? So whatever is there, I'll completely pack it up and give it to you. You can try adding it. So the options are like, whatever I showed you. So you can
oversee that, yeah, because just if you give us and then if there is like, I mean, if you guide us, keep guiding us, then we'll be able to finish up this application. Nandini,
sure,
if that,
sure.
if that is possible.
I think you're already part of the participant group, right, in the WhatsApp. So any doubts, any clarification, you can drop a note. I can anyways help you. Say like, so far we didn't go beyond multi-threading or collection. So whatever you would have listened in the sessions so far. So that is the concept that we are using here. You're just going system, you're going to use collections, multi-threading, OOPS, interface, that's it. So nothing more beyond this GSP solids or nothing. So with this itself, just to let you know the power of using the code, the Java code. So it can help you create so much business logic You don't have to learn more and more with just like a few sessions that we have done so far, like 8 or 10 sessions so far. So this knowledge that you have, if you see, there is nothing advanced concept that I'm using here, just right, just multi-threading and the collection to the max. So that's the part I covered so far. So till that I'm using it. So with this itself, you can cover so many business logic. So it is all about the idea and how we are going to create the code, right? So that, like, yeah, sure. I'm really glad that you asked. I'll definitely share this. New orders I've done. So B for status and order history. Like I said, you can fill up that hash set and show like the user enters the B or C. You can show up the status, order history. You can even enter like the first level of options I gave, like 1, 2 only, login page, register page. You can go in for another like case 4, where you can just add a customer service, where you can just put in like predefined questions like what went wrong. So my order is not nice or not tasty or package is broken, something like that. You can just say, yeah, please, refund my amount. So the customer could say yes or no, the customer service. Then you can just, you can add the money wallet for the customer. And then you can add, now that you have restaurant service, so within restaurant service, you can add like few more objects like this one, vendors who will be giving you the food quantity, right? The content preparation, whatever you need. Let's say you are ordering for dish 1. So dish 1 is going to have 1 egg and 1 kg of rice, something like that. So you need some quantity of food that is, like food material that is going to come down in restaurant, and you are going to one day going to reach out to some vendor. So you can introduce a vendor service who is going to stock back your, go down or inventory. So the other day we saw, right? So we are stocking back, and then the purchase, the shopping goes on. So like that, you can enter the shopping. Like instead of shopping, you can just make it as vendor who is going to fill up your raw material for the restaurant. All this, like, you can introduce so many business logic in this. You can make such a big complex application. So that is what the idea is, what is going to earn a lot of things, innovations, or be it like monetary benefits. So everything from the code happens based on the idea that you implement. That's it. It's simple, like no complex logic or anywhere.
Yeah, maybe if we have practical sessions on Saturday like this, we can extend, this application, whatever we have developed now, or we can even create a new application.
Yeah, sure. Any questions you want? I'm not sure, like this itself is like it's an extra session, right? So I'm not sure we'll be having any extra sessions every time. But I'm always happy to help you, like in the WhatsApp group. So I'm also there in the participants group, right? So start doing the code, and you can reach out to me or to any of the the trainers for in the
Like
group.
we need some guidance, like what all can be done. If that is said, then at least like assigning a task, then we will be able to do. Instead, just we can take and we ourselves have to develop. That is not going to work out.
Okay, sure. You can take this up. Take a couple of days of time, maybe like today is Saturday, and you can take till Sunday, Monday, and Tuesday. You can drop a note on the WhatsApp group, and I could just let you know how to proceed further. So if you face any error, so try to finish this up, like B and C in this application, right? So what I showed you, right? You can try to at least finish one B, maybe like register page. Okay, so there we have, right? Status. A status is going to take more time. So let's say history. You can just fill in the history, right? So if the user enters C, you are going to show the customer hash set, whatever hash set that you have created in the customer DDO. You can keep filling this. When to fill this? Once the order is picked up, or once the order is created. Here we said a new order creator, correct? So as soon as you come here, you are calling the restaurant service. Even before creating a restaurant service, here we can just say insert into customer hash set the value of order. Maybe you can just give an order ID, something like that, and then you can enter it to the hash step. All right. So this one, you try to do it. I'll just pass on this code. You can just try to do it. Take 2 days time. Maybe like Tuesday, I can just reach you back on the WhatsApp group. That be okay? Step by step, like take it step by step. Am I audible? Hello.
Yes, Kannan, I can hear you.
Sure, ma'am. Sure, Nandini. So that's about multi-threading and collections. Hope that was interesting. I was
Yeah,
able
it
to.
was. Thanks a lot, Kannan. I think you were very patient. Thank
Thanks.
you.
Thanks.
Thanks for taking so much of time. All right.
Thanks.
Thanks, everyone. As Kannan mentioned, if you have any questions, please send out a message in WhatsApp group. I mean, having a session every Saturday, I don't think it's actually very relevant because I don't see many participants joining in. And it's just for one or two. We don't know, right? It's efficient way of doing it or not. So just if you have any questions, please send out your question in that WhatsApp group. I'm adding all the trainers in that group, so in case if you have any questions, you can get clarified there.
It will be really very helpful if if the code is shared, and then what Kannan said I can follow. Maybe if he is assigning a small task, then it will be really, I mean, I can do, and then maybe I can show him the result, something like that. At least that can be done. So that hands-on session will really help us for, that also plays an important role in attending the interviews. So
Sure, that would be that can be done, ma'am. So you can drop a note in the WhatsApp group. So I'll give you like a few steps what you can try to achieve, if possible, or maybe I can give some code snippets whenever possible, and then you can just do kind of hands-on assignments on that. So that should not be a problem.
okay, yeah, sure, Kannan. Thank you so much.
Because like separate session as such, as Nandini mentioned, right? So the number of participants, sometimes it's okay, sometimes it is very low quorum. So it is like,
Yeah,
have to
I
spend,
remember
like,
the person who has okay, let me stop recording now and then we can talk. Thanks, Kannan. Just give me a minute.